The function f is defined on positive integers, and f of 1 is 1996. And given that f of 1 plus all the way up to f of n is equal to n squared times f of n. And what's f of 1996? So first of all, since f of 1 plus all the way up to f of n minus 1 plus f of n is equal to n squared times f of n. So which means f of 1 plus all the way up to f of n minus 1 is equal to this term removed to the other side. Right, then we can factor it out. N squared minus 1 times f of n. Right, at the same time, just replace this n with n minus 1. That is equal to, so this part is equal to n minus 1 quantity squared times f of n minus 1. Right? So these guys equal to each other. Right, so n squared minus 1 f of n is equal to n minus 1 quantity squared times f of n minus 1. Or simply just we divide f of n minus 1 over to the other side. And before we divide it over, we have to check that none of them is equal to 0. Right? So suppose some f of n is equal to 0. Right? N starts from 2, of course. So that tells us that the f of n minus 1 must also equal to 0. Right? Then we can replace this with f of n minus 1. Then conclude f of n minus 2 must be 0 as well. In the end, we conclude that f of 1 must equal to 0, which is a contradiction. So none of the f of n is equal to 0. So we're fine. Do the division. Right? Safe. F of n minus 1 simply equal to n minus 1 quantity squared over n squared minus 1. Right? Then we can hopefully just do the series of multiplication and hopefully cancel out the majority of them. Right? So that means we have f of 2 over f of 1 times f of 3 over f of 2 all the way up to f of n over f of n minus 1 and cancel out f of 2, f of 2, f of 3, f of 3, f of n minus 1, the previous f of n minus 1, and only left with this and that. Right? But this is equal to 1996 as given by the condition. So that's equal to f of n over 1996. Right, so further, that's equal to the right-hand side series of products. Right? So products of k from, so we use k minus 1 quantity squared over k squared minus 1. Right? K starts from where? So we started off from f is equal to 2. Starts from 2. We end with n. Right? So then we can just say that's equal to the product from 2 to n and k minus 1. K minus 1. Quantity squared, k squared, k minus 1 times k plus 1. Difference of perfect square. Then k minus 1, simplify it down to just one of them, right? That is equal to the product from 2 to n of k over 1, k minus 1 over k plus 1, right? So again, we can just re-index. After we break them apart into two products from 2 to n of k minus 1, and the other product also from 2 to n of 1 over k plus 1. Right? So now we can re-index it. Replace k minus 1 with just k. Right? So we start from 2 minus 1. We start from 1. n minus 1. We end with n minus 1. Right? So start from 1, end with n minus 1 as we replace it with k. Right? So same strategy. we start from 2, we start from 3, we end with n plus 1, right? So 3, n plus 1. So we replaced it with k, just 1 over k. Now we just say, first I'm going to isolate the first and second term of this product, and I'm going to isolate the last 2 terms of this product. And the remaining terms, they're all equal to each other. I mean, they can all just cancel out each other, right? So they all start from 3. They all end with n minus 1, right? 3 until n minus 1. They all have, this guy has k, this guy has 1 over k, right? So after I just isolate the first and second term of this and last 2 terms of that. So that is just 1 times 2 times what's the last 2 terms of this product. That's when k is equal to n minus 1 and no, k is equal to n, and also when k is equal to n plus 1. Yes. So that means this is just simply cancel out, right? This is just 1. So that is just that is just 2 over n times n plus 1, right? That is this, right? F of n over 1996, which means 2 over 1996, or replace n with 1996, times 1997 is equal to f of 1996 over 1996, right? 1996, 1996. So 2 over 1997.